Hey, welcome to The Explainer. So today we're diving into some really cool research that could totally change how we think about something we all have in our medicine cabinets. Yep, the humble bandage. We're going to break down a study that mixes a synthetic polymer with a pretty common vegetable to cook up a whole new kind of wound dressing.
All right, so let's get right into it. A bitter vegetable revolutionizing bandages? I know, it sounds a little out there, right? But believe it or not, scientists are seriously looking into how natural, biodegradable stuff can make our medical treatments better and, more sustainable. The big question here is, can adding bitter gourd to a polymer film actually give us a better bandage?
So, what's the big challenge we're trying to solve here? Well, it's pretty simple. We've got tons of wound dressings out there, but we're always on the hunt for something better. We want something that's not just effective, but also safe for our bodies, that's biocompatible and good for the planet. The perfect bandage would protect a wound, actually help it heal faster, and then just disappear, biodegrade. Okay, so a material called polyvinyl alcohol, or PVA for short, seems like a great place to start. It's flexible, it helps our skin regenerate. That's fantastic for a wound dressing. But, and it's a big but, it has a major Achilles heel. Its chemical structure is loaded with these things called hydroxyl groups, and you can think of them as tiny little magnets for water. So what happens? The PVA just dissolves way too easily. And that's not exactly what you want from a bandage that's supposed to stick around and do its job.
So to fix this problem, the researchers basically assembled a dream team of 3 key ingredients. Each one has a very specific job to do. And the whole idea is that together, they can overcome PVA's weaknesses and create a really powerful functional film. First up, we've got our foundation, the PVA. This is the stuff that gives the film its flexible, body-friendly structure. It's basically the scaffold that everything else gets built on. Next, we've got the secret sauce, the bioactive ingredient, bitter gourd. Now this stuff has been used in traditional medicine for ages because it's packed with things called flavonoids that fight inflammation and bacteria. So yeah, it's bringing some serious natural healing power to the party. And here's the real hero of our story today, citric acid. You can literally think of it as a kind of molecular glue. It's a totally non-toxic natural acid, and what it does is it forms these strong chemical bonds, they're called ester bonds, with the PVA. This whole process is called cross-linking. And it's like tying all the polymer chains together, which makes the entire structure way stronger and much more resistant to water.
And this is perfect. It shows you exactly what we're talking about. On one side, you have the synthetic polymer resin, just these simple little granules. And on the other, you have the fresh, natural bitter gourd. It's this mashup of the synthetic and the natural that's really the key to the whole thing.
Okay, so how do you actually turn these raw ingredients into a high-tech biofilm that you can test? Well, it's a really careful, step-by-step process. Let's walk through it.
First things first, you can't just chop up the bitter gourd and toss it in. No, it's much more precise. It gets washed, dried out in an oven to get rid of all the moisture, and then ground down and sieved into a superfine, consistent powder. This is absolutely critical to make sure it spreads evenly through the film.
All right, then comes the fun part, making the different recipes. They carefully weighed and mixed the PVA, that bitter gourd powder, and, this is the most important part, different amounts of our molecular glue, the citric acid. They poured this mix into a petri dish, let it dry for a day, and voila, you get a thin film.
And this is the final product. Check it out. It's this thin, flexible, kind of see-through film, and you can see the little specks of bitter gourd powder in there. This is the material that then had to go through a whole gauntlet of tests to figure out which recipe was the champion. Okay, now we're getting to the really good stuff. The entire point of this whole experiment was to find that Goldilocks recipe. Not too much, not too little. The big question was, what's the perfect amount of citric acid to get the best possible mix of strength, flexibility, and water resistance?
So check this out, because this is where we see that it's all about a delicate balance. If you look at the chart, the film with 0 citric acid was surprisingly the strongest. But then, when they added just 1%, the strength actually went down. But look what happens at 2.5%. It bounces back up a bit, before dropping again at 5%. This tells you right away that it's not a simple case of more is better. It's way more complicated than that.
Right. So the key takeaway here is that this is all about trade-offs. You're looking for that perfect balance. The one with no citric acid, super strong and stiff, but it would just fall apart in water. The one with 5%, great water resistance, but it was the weakest of the bunch. So the goal was never to max out one single property. It was to find the best overall package for a real-world wound dressing. So, after the scientists crunched all the numbers, looking at everything from strength and stiffness to how well it held up to heat and water, one recipe clearly emerged as the winner. It just stood out from the pack.
And that magic number? It was 2.5%. That was the winning concentration of citric acid that gave the best all-around performance.
And hey, don't just take my word for it. The researchers themselves said that this recipe, the PVA, bitter gourd, and 2.5% citric acid, hit the absolute sweet spot. It had the best balance of everything you'd want: strength, flexibility, stability, water resistance, the whole shebang. It was by far the most promising formula.
So, why was 2.5% the champion? Well, it had that perfect balance of being strong but still flexible. The molecular glue did its job, making it way more water-resistant than the original version. And other tests showed it had a more stable, well-ordered structure on a molecular level. Basically, it was strong without being brittle. The ideal candidate.
Okay, so what does this all mean in the grand scheme of things? Beyond the lab, why should we care about this specific recipe? What's the bigger picture for the future of healing?
Well, what this study really is a fantastic proof of concept. It shows that, yes, this is a totally viable way to create the next generation of wound dressings. We're talking about dressings that aren't just strong and effective, but are also bioactive, meaning they actually do something to help healing, and sustainable, all thanks to those natural ingredients. And this is absolutely crucial. It's not just about how strong the film is. Remember that bitter gourd? Well, because of it, all of the films were antibacterial. They tested them against two major categories of bacteria, gram-positive and gram-negative, and the films worked against both. And that's a huge deal, because it means these bandages could actually help prevent infections, which is one of the most important jobs a bandage has.
So, how soon could we see something like this in our own first aid kits? Well, obviously there's still more research and clinical trials to be done, but this work is a huge step forward. It brings us that much closer to a future where our bandages are smarter, more effective, and powered by nature. Thanks for diving into this with me today on The Explainer.